All right, I think we're good to get started here. So thank you again for joining us for today's user training session. Today we have Olivia who's going to take us through analyzing active transportation users. So a little bit of housekeeping. This session is being recorded and you will receive a recording emailed to you tomorrow. And if you have any questions as you're going through, feel free to use the questions section of GoToWebinar, and we'll leave some time at the end of the presentation to go through those questions with you. And with that, I will hand it over to Olivia.
Hi, everyone. Thanks for coming. I'm having some technical issues where I can't get my taskbar to disappear for some reason, so sorry about that. Yeah, so today talking about active transportation data that we can provide to our customers in TrafficLink. If we haven't met before, or if you haven't attended one of these training sessions before, my name is Olivia Babcock. I'm a professional engineer working as a traffic engineer at Miovision. Recently started working as a solutions engineer as well, covering Canada. But I help out on the traffic engineering front all across North America. I teach our customers a lot about ATSPMs and about our software solutions. So today we are going to cover kind of two main topics. But before we get to that, as always, I like to cover where we're getting our data from. Very important to know where it's coming from so you can understand how we're collecting it and how you can use it. Then we're going to get into video detection and counts, some use cases there, and then we'll get into our safety metrics and again some use cases and examples there. So, and of course at the end we'll leave time for questions. So if you have any questions, you can put them in the question box, as Catherine said. So our classic data source slide here. Within TrafficLink, the data that we are collecting is from three major sources. So we're looking at signal status from the controller, so just looking at green time, yellow time, red time, reading that directly from the controller. Detector activations, whether that's our detection, whether that's detection you already have, loops, pucks, what have you. If you already have detection, you can read those. Metrics as well, and then of course we have our Wi-Fi MAC address probe within the core DCM unit or within the SmartLink. So those are our three main sources. They provide us with various data that we can kind of put together to come up with our ATSPMs, which is kind of listed below there. The parts that we're going to focus on today are signal status from the controller and detector activations, and kind of in combination they can provide us our pedestrian delay metrics and our yellow and red light behavior, which is our safety metrics. And then we're also going to briefly look at pedestrian button usage. So if you have a pedestrian button, we can provide you with some insights on what's going on there. So those are our major data sources. And now we get into our active transportation data. So to start with, if you do have a 360-degree camera out there, you are able to access counts. That is continuous 24/7 counts, multimodal counts. We provide classification of lights, buses, single unit, articulated trucks, bicycles, and pedestrians. And obviously today we're going to focus on bicycles and pedestrians. Here you can see an intersection that's pretty heavy on pedestrian volumes, and you can see on the right square we have all of those being classified and counted there. So if you haven't looked at your counts lately, this is what they look like. In TrafficLink at the moment, when you go to your continuous counts, it does take you to an external link. So it does take you to another website of ours called DataLink. That is currently where our counts are stored. That is going to change over the next 6 months as we merge TrafficLink into what we're calling Miovision 1. If you haven't heard, Miovision 1 is kind of the consolidation of all of our platforms. So that will consolidate TrafficLink, DataLink, SureTrack, which is our adaptive product, and Performance, TrafOp, and a couple other things as well. So it'll be all in one place For now, you're still able to access counts via traffic link that takes you to that external link to data link, and this is what our counts look like. If you haven't before, you can turn on and off different classifications of vehicles in that bottom volume chart. So you can see in gray is all of our vehicles, and we're just looking at bicycle and pedestrian data. We also show the total pedestrians and total bicycles at the top. You can also look at that if you just wanted to look at the AM peak. You could look at that, just the PM peak, just a few hours. You can customize that how you will. On the left side as well, you can see kind of which direction the pedestrians are going in. So if you look at the top here, we can see from right to left, we have 6,800 pedestrians crossing there, and from left to right, we have 5,200 pedestrians. If you do download this data, which you can do into a CSV format, what it looks like for the directionality of pedestrians is going to say clockwise or counterclockwise. So that will just indicate those two directions of travel for the pedestrians, so we know where they're coming from and where they're going. So in order to actually get counts, we need to look at configuration. If you haven't looked at your configuration, this is what it looks like within Traffic Link. So bicycles are actually counted as vehicles, so they're just counted within the regular vehicle configuration, which you can see in the first image at the top. We do lane by lane configuration, so we're counting by lane. That just makes counts more accurate. So where a bicycle is expected to bike on the road, they should be counted in this configuration here. So obviously, if you have kind of a bike lane off to the side, then you can kind of configure appropriately for that. In order to have pedestrian counts, we need crosswalks to be configured. So that's the image on the right, and that's like a crosswalk detection zone. So that's that yellow zone right there. And we can see kind of entry and exit denoted by those green and red triangles. So we can see where pedestrians are expected to enter and exit, obviously on both sides. And that is where a pedestrian is going to be detected, classified, counted. So important that our configuration is correct so that we're accurately collecting that data. So as I mentioned, I just want to briefly touch on this. Obviously, there'll be more training to come as Miovision 1 rolls out, but you do have access to Miovision 1 right now if you're curious what it looks like. It looks pretty similar, but one thing that's different is that we will have our volume data within Miovision 1. I won't take you to that external link, as I said, and it's going to be called mobility reports. So that's where your count's going to sit in mobility reports. And you'll have kind of two ways of visualizing this data. So you'll have single day volumes, which is kind of what we provide currently with our counts. And then you'll have this longitudinal volume analysis, which is a way of looking at something kind of across a longer term date range. So mobility reports, although the colors are different, they generally are reporting on the exact same thing as what our volumes are reporting on now. You can see total number of lights, total number of articulated trucks. We just have a bit more detail there, but generally looks the same, just different colors. And then our longitudinal analysis here, you can see actually just the total volume each day across what looks to be about 2 weeks. And you can see the average across those 2 weeks. So you can start to see trends, you can start to see where your highest volume days are. So looks like our highest volume day was kind of in the middle there. And we can start to understand our volumes kind of typical, where we see volumes building up to Friday and then dropping off during the weekend, or is there a different pattern going on? So we can start to see more trend level information here. So that is currently available in, you are able to access Miovision 1. All of this functionality for mobility reports is not quite built out yet, but you should be able to see your single day volumes in there for now. But as I said, you can still access Traffic Link if that's what you prefer for now, but eventually they will all be moved over to Miovision 1. So back to present day. One of our pedestrian metrics that we do have as an ATSPM is our pedestrian delay. So what this is showing is the time between pedestrian detector actuation. So between the time maybe that you press the button, that the pedestrian pushes the button during the don't walk phase, and basically the time from then to when the phase turns to walk. And that data has been into 15-minute intervals. So obviously from this information, if you're trying to make your intersection more pedestrian friendly, maybe it's a more pedestrian friendly area, a downtown area where we're trying to slow people down, encourage walking, frequenting small businesses, what have you. Maybe you see that there's significant pedestrian delay. Maybe you want to reduce that. Maybe you want to reduce cycle length, something like that. So that is the information being taken from pedestrian delay. In order to get that information, we do have to have pedestrian detection configured. If you can't currently see that data, so if you go into Traffic Link and you're looking through your performance metrics, and you see that the pedestrian delay metric is grayed out, but you're aware of the fact that you do have pedestrian buttons, it's likely that it's just not configured within Traffic Link. So you can configure it by kind of simple steps here. If you're not comfortable doing that, you can always reach out to your partner or the CSM. If you have a relationship with them, they'd be happy to help with that. And then you can start getting access to that pedestrian data or pedestrian delay information. So now that we kind of know where our data comes from, how to get that data, some use cases for that data. This might be the more obvious one, but they're pretty neat, I would say. So obviously, as time passes and we have our 360-degree cameras out there collecting all this data, we can start to look at trend level information. So tracking volumes is just a very basic one, but I still think it's very, very interesting. So here's an example. This is May 29th, 2019. We have a very busy intersection, especially in the pedestrian front. So we have 52,000 pedestrians here, 1,500 bikes, relatively normal AM and PM peak. So very busy intersection. And as we know, about a year later, there was this big world-changing event that affected traffic. And we can see that in our data, right? So we can see that vehicle volumes were just about halved. And the one that I thought was even more interesting was that pedestrian volumes just were completely gone. So we went from 52,000 pedestrians to 6,000 pedestrians around the same time a year later. I didn't check the weather on these days, so it might have had something to do with it, but yeah, completely changed. The other interesting thing here is that bicycle volume stayed the same, pretty much exactly the same. So that was not impacted. And then now, because we're still at this intersection, present day, a couple weeks ago, we can check in to see how we returned to 2019 levels. And we can see that in vehicles, we have not. Pedestrians, we have not. Bicycles, we have, and we've actually increased significantly the number of bicycles. So in this case, as an outsider who doesn't necessarily know what's going on at this city, maybe I could say maybe there were more bike lanes constructed in the area, so maybe that encouraged bicyclers. Maybe the reduction in vehicle volumes made it so that cyclists felt safer to use that intersection. Perhaps that's something. Obviously, if you worked at this city, you might know some of these projects that went on, so you would maybe know why this is the case. Up here in Canada, I'm not sure the rest of the world, but we had a shortage of bicycles kind of around the 2020 and 2021 summers. So obviously lots of people were starting to bike. So it's interesting to see that they're still biking there, and that increase is holding strong. So lots to learn by tracking these volumes over time. Another one semi-related to the pandemic, but could still be used for kind of any event that you're holding. This was an event in California, in kind of a downtown area where they were planning to shut down the street, a section of the street on Thursdays and Fridays, to encourage small businesses to kind of expand their restaurants into the streets, open up patios, and encourage people to walk down and go to those restaurants. So obviously we had cameras out there. We were able to check in on volumes to see how many more people were walking as a result of the street being closed and maybe feeling more safe and wanting to come down and support these businesses. So we could see in this graph on the right there, we have our baseline volumes in blue, kind of around the 3,500 mark of pedestrians. And you can see how much those increased after this dining under the lights event was happening. So we looked at 3 different intersections around that area. And overall, that resulted in a 32% increase in pedestrian traffic there. So this one is kind of more of like an economic development. We can support these incentives with data to show our counselors perhaps, hey, this event was really successful, rather than just kind of asking business owners, hey, like, how did you feel about the event? We can show there was actually an increase in pedestrians frequenting that area. So I think the last of my examples for this sort of data, obviously there's a ton of examples, but I only have kind of 45 minutes to discuss. But another really interesting one, I think, is stadium operations. So we are installed near a few stadiums, and as a result, we get to see kind of craziness like this occur, where we can see volumes being counted, and we can see patterns forming of when a game starts, when do people start showing up? When do people start needing these crosswalks? When do people start needing kind of police supervision of these signals? They kind of put these signals into flash and direct traffic themselves. So we can see when people arrive. As you can see on the left here, we have our volume. So we can see, I think this game was at 1 p.m. So we can see when people start to arrive, and we can see when people start to leave. So we can kind of appropriately allocate resources to these intersections. We can appropriately set expectations for when people are going to arrive, when we need to start bringing out pylons to close down lanes, when we need to have the police show up, all that sort of organizational stuff. So we can see on the left there as well, the pedestrian volume chart on the bottom. We can see this isn't really a pedestrian area normally during the week. So we can see, and even on the weekend, weekday and weekend, there's never usually any pedestrians here. But you can see on game days, there's a dramatic increase in pedestrians. So obviously there needs to be a plan in place, and you can see there is a plan in place here, but maybe with access to this video and these counts, we might be able to improve on this plan. So now we will get into safety metrics. So we have 2 safety metrics, and they are surrogate safety measures. And why do we use surrogate safety measures? Well, surrogate safety measures are leading indicators of safety as opposed to lagging. Lagging being collision crash data. So we look at it after the fact. We can start to look at red light running and pedestrian noncompliance before anything happens. And what we learn from that data, we can then apply and hopefully make changes to reduce risk and reduce the number of collisions kind of before they happen. So yeah, that is why surrogate safety measures. So to start with, we'll look at pedestrian performance. So non-compliance is defined as a pedestrian crossing event that takes place during the don't walk phase. We're not trying to victimize pedestrians, but to understand their behavior and hopefully accommodate safer operations at the intersection. So if we look at enough of these examples, we can start to understand why are pedestrians behaving the way they are, Obviously, not everything is going to be a trend. There's some anomalies, but largely what I've seen is if you watch enough video, if you see enough data points, you can start to piece it together, and there's usually a couple of trends at an intersection. So if you haven't looked, this is what a pedestrian compliance chart looks like. Same thing as with pedestrian delay, you do need to have pedestrian push button set up or pedestrian detection set up in configuration. So if you can't see these metrics, if they're grayed out in your performance metrics, it's likely that it's just not configured. So again, you can reach out to your partner, you can reach out to a CSM and ask them about configuring that. So what we see here, this is just two examples, same idea. So we have the flashing don't walk, which is yellow. And then we have our don't walk, which is kind of orangey, peach, red colored. And then we have each crossing is marked by one of those points, which marks when a pedestrian has moved through the crosswalk and is approximately in the middle of the crosswalk. That's when they get counted and classified as a pedestrian. And then we do have a summary metric, which is the dotted line, and that's number of crossings on the don't walk. So we will look at common pedestrian non-compliance occurrences. So I've done a lot of looking at this data in teaching our customers about this data and showing them some examples. I've come to learn of a few common occurrences of non-compliant pedestrians. So we'll go through a couple of those examples, but just to list them out here, we have congestion, we have low vehicle volume or high pedestrian delay. We have most commonly, I would say, that the pedestrian button was not pressed. We see two-stage crossings where that's applicable, so where we have a pedestrian median or we have a median that acts like a pedestrian median. And then, of course, we always have to have the no obvious reason or trend. Those still pop up from time to time. Humans are interesting and can exhibit some interesting behavior. So we'll go through a couple examples here of pedestrian noncompliance, and then we will do red light running. So pedestrian noncompliance here, we have a chart. So this is typically how I go through this data. I will bring up all four movements, if it's a four-way intersection, and look at them for one day and see if I see any interesting trend. And then I will start to look at kind of extreme examples. So examples that aren't necessarily during the flash don't walk. We kind of expect people to walk during the flash don't walk. We kind of design it that way so that people can make it through safely if they've gotten caught in the middle. So that's not necessarily the problem area. The problem area is where we have kind of beyond into the don't walk, where potentially they're really not supposed to be going. Maybe they're going directly at the same time as conflicting traffic and conflicting vehicle movements. So those are the more concerning ones. So in this case, I looked at a more extreme example here. For all of these data points, you can scroll over them within TrafficLink and they'll show you the time that it occurred as well as the time past flashing don't walk start. So you can see this was at about 9 a.m., 187 seconds after flash don't walk. So I can then bring up the video. If you don't have access to the video, you still have ways of interacting with this data, but if you do still have access to the video within 7 days, if you still have it there, then you can download that 15-minute bin. So this would be the 9 a.m. to 9:15, and you can watch it and you can see if you can spot the pedestrian. So here we can see the pedestrian is in the middle of the intersection crossing, and there's no vehicles around really. So just to confirm, because it's hard to tell from these videos sometimes what's going on with the signals, you can also bring up your telemetry. So telemetry you have access to indefinitely, so you can always kind of scroll back in the timeline and find out what was going on at that intersection. So in this case, the signal was resting in eastbound, westbound, and the pedestrian crossed north-south. So this was on the west crosswalk. They were going north, I believe, and they just crossed in a gap of vehicles. So this would be a good example of just low volume. You can see there's hardly any vehicles around, so the pedestrian just kind of looked both ways, maybe stopped in the median, looked both ways again, and then kept going. So a pretty common one if it's a low volume intersection or maybe a low volume type of day. We see a lot of these more extreme cases in the kind of late evening and early morning period. If there's any pedestrians around, they generally don't wait for the walk symbol if there's no vehicles around. So that's what's happening here, just low volume, and this pedestrian took it into their own hands. So a similar example. So again, we have also 9 a.m., interesting. And another kind of extreme example. In this video, I can clearly see that the, I don't know what the direction is, but if we say this white van is northbound, we can say that the northbound direction does have the green light, and you can see the pedestrian is crossing directly in front of that conflicting movement. What I checked was pedestrian delay, and we can see that pedestrian delay is quite high at this intersection. I believe that this intersection has a really long cycle length. So it also has generally a low volume at this time of day. So you can see, again, there's not many vehicles around. So the pedestrian just crossed when they wanted to. But if they know this intersection well, they likely knew that there's a high delay between when they push the button and when they actually get to walk. So again, they just took matters into their own hands and crossed kind of in conflict with oncoming vehicles. So I hope that these videos work. So this is a good example of a two-stage crossing situation. So after watching lots of videos at this intersection, we were able to see that, especially in high congestion periods, pedestrians were walking kind of whenever they wanted, stopping in that median, and then kind of looking both ways and finding the gap between vehicles and crossing. So the question here is the median creating a sense of security and encouraging non-compliance? So hopefully you can see that. Sorry, it skips a little bit at the beginning, but there we go. So the pedestrian's crossing, and they stop and wait, obviously, because there's vehicles directly in conflict, but then they go, even when the conflicting vehicle didn't even really slow down. But yeah, we saw a lot of these examples of kind of waiting in the median and then playing Frogger in traffic. So yeah, an important example of, is the median creating a sense of security? So maybe that's a design issue. Maybe we can look into signal timing, something like that. So the last example of how we could use pedestrian compliance data is actually a little kind of project that also happened in California, where this customer is interested in reducing pedestrian non-compliance or increasing pedestrian compliance. And so they were curious if they reduced the cycle length, if that would have an impact. So they reduced their cycle length from 6:30 a.m. to 2 p.m. from 90 seconds to 75 seconds. Again, we just looked at 3 intersections here, and it was a pretty quick study. We just wanted to see quickly if that made an impact. So we looked at about 2 weeks of data. You can just see these are the phasing information. So you can see it was 75 seconds. Now it's, or sorry, it was 90 seconds. Now it's 75 seconds. And we did find that this reduced non-compliance by 6%. So it increased compliance by 6%. So just a quick little change. Again, this is the street that they were trying to encourage pedestrians to be at. They were trying to reduce vehicle speeds. So they were just trying to experiment with what they could do to make pedestrians feel more comfortable and for the space to be more welcoming. So they did find that this was effective. So now we'll get into red light running. Just a quick stat. I believe this comes from the United States. In 2019, over 800 people were killed in crashes that involved red light running. So, and over half of those were pedestrians and bicyclists and people in other vehicles who were hit by the red light runner. And beyond just there was 143,000 people who were injured in red light running crashes as well. So big impact that red light running potentially has. So the red light running chart looks very similar to pedestrian compliance chart. So here we have, again, our yellow corresponding to the yellow portion of the phase, our red corresponding to when the phase is red. Again, each of these detector hits represents a vehicle that has moved through the intersection and is in approximately the middle of the intersection at that point in the phase. And then we do have our hourly count of red light runners as that dotted line. The one thing is above 10 seconds, our data points look different. We just have them as a triangle. We just didn't want to expand the graph too much. So if it's beyond 10 seconds after the start of the yellow, then we give it a triangle there. So the number one question that I get asked about pedestrian compliance as well as red light running behavior, specifically about red light running behavior, is kind of, is this normal? Is this a normal intersection? Is my intersection behaving normally? Is this more red light running? Is this less red light running than you would expect? So I wanted to try to normalize a bit here. So the things that I look for, generally, again, at a four-legged intersection, I'll bring up all four charts for one day. And usually you can immediately tell which is the major and which is the minor. The major generally has more volume and therefore has more red light running detector hits. So that's very normal for our majors to have more than our minors, just by way of more volume. And then what we look for is that the majority of our data should be in the yellow, as well as in the all red portion of the graph. So this example I specifically used because it looks pretty good. I would say 99% of our data is in these two. The reason we want our data there, pretty obvious. We've designed the clearance zone or the clearance time, the yellow time, the red time, specifically to kind of capture these vehicles, right? To make sure that nobody is in the middle of the intersection when the next phase gets the green, so we don't have that kind of conflict. So here we can see the majority of the vehicles are actually in the yellow, which is great. And then we have a few in the all red, and you can see there's more in the all red in the PM peak, which again, more volume, that makes sense. Maybe there's congestion, that is often associated with red light running. And then we hardly have any beyond that all red phase. So in this example, I just picked all red as 2 seconds. Obviously in your specific town or city, you will know what the all red is, so you can kind of appropriately estimate where that data should be. If you start to see well beyond 6, 7 seconds into the 8, 9, 10 range, kind of as a trend, then that's where you might start to be concerned. Could look into the video, see if you can see any trend level data there. Sometimes we do see these triangles at the top, detector hits over 10 seconds. With red light running behavior, we do capture all vehicles, and that includes cyclists. A lot of the time when we see these more extreme examples, it tends to be cyclists as well as emergency vehicles. So obviously emergency vehicles are going through the red light, they have their lights on, they gotta go through slowly, but they're definitely in the red. So that's kind of a pretty common one there. Some things to ask yourself, which we kind of just went over. If they're in the late red, why? So if they're in beyond that all red portion of the graph, can you start to figure out why they're there? Is it a trend? Have you recently maybe looked at your yellow timing, your all red timing? Maybe you could consider examining that. And again, the reason that we look at all four movements at a four-legged intersection is there one movement that's experiencing significantly higher rates than others? Is this related to performance? So again, oftentimes where we see a congested movement, where we see a movement with a lot of split failures, we often see more red light running. People are getting frustrated. They're entering the intersection and they can't necessarily clear it. They get stuck in the middle of the intersection for the next green phase, things like that. That's a pretty common one as well. So, which is what leads us here. So, common red light running occurrences, which I basically just covered, but patterns that we see, again, I look at a lot of this data. A really common one is congestion. Another really common one is cyclists, as I said, in emergency vehicles. Sometimes we see, I've seen an example or two where the intersection operation confuses the driver and they go through the red light. And again, of course, we're humans. Sometimes there's no obvious reason. So again, we can go through some examples here. So this is a prime example of a congestion related red light runner. So this is the one where we overestimate, we think we can make it through the intersection, but we can't, and there's no room, and the light starts, and then maybe we get honked at because we're in the way. So you can see this white van is looking to actually turn right, and they can't, and this vehicle is going through, and they can't quite go through as well. So obviously this vehicle got picked up as a red light runner. So another one here is a cyclist. So again, as I said, some of these extreme examples are sometimes cyclists. They do get picked up as vehicles. We do count them, as I said before. So sometimes we see them not always obeying the rules. Also during congestion, they can kind of weave better through vehicles, even if they're not supposed to. So that's an example here. So the bicycle is going to come from the kind of right side of the screen and cross to the left there. So you can also see there's lots of congestion, which leads to more red light running. And some of these vehicles also were likely dinged as red light runners. So we were into the green phase. That left turning vehicle was likely ran the red light as well. Something that's important to consider as well, which I haven't mentioned, is that the only detector hits here are for through movements. So all of these detector points, these detector hits for red light running vehicles are the through movements. So that left turn, even though it was likely in the deep kind of all red, maybe into the next green phase, did not get picked up here because it was a left turning vehicle, but that cyclist definitely did. So we can play it again. Thankfully, the cyclist and the vehicle saw each other, so they kind of slowed down. But the cyclist, I think, was kind of booking it to make that light, and I don't think that they necessarily did. So they were picked up as the red light runner there. There we go. Okay, another really common one that I said, the emergency vehicles. So not a video, but we can kind of plainly see this example here. Sorry, it's a bit blurry. We have an extreme example, kind of one of the only ones of the day. And we can see it was in fact a fire truck moving through the intersection. And again, if you can't see, like this is not the best example, you can't necessarily see what's going on with the lights. You can always look at telemetry, which I am sure I did, I just didn't include in this example. You can check your telemetry to fully understand what's going on with the signal so that you know for sure that that vehicle did not have the green. And this is one with no clear reason, just one that, yeah, I like to show sometimes because it baffles my mind. But yeah, as you can see here, in this example on the right, the chart generally shows that things are going well. Maybe most of the vehicles are moving through on the all red, which might be concerning, but this example is kind of the only extreme one of the day. So the vehicle is going to be moving from the top left to the bottom right there. I can maybe make it bigger. It's a bit blurry, sorry. Oh, there we go. You can see that that vehicle is slowing down because it has a red, and then that vehicle speeds up. So that was a near miss for sure. And there was no kind of obvious behavioral reason for that. So sometimes you watch these and they're just interesting, but not necessarily something you can kind of build a trend on. So keep that in mind. Can I go to the next one? Okay, yeah. So that's everything that I wanted to show you today. As always, we do have our help center, help.miovision.com. I use it pretty frequently. It has a lot of helpful information concerning traffic link, different hardware, data link, has everything there. I use it all the time. And we also have a few webinars coming up, I believe. So again, check our website for those. And we have a few webinars that we've previously done on kind of more in-depth safety analysis around near miss data. So if you're interested in those, I believe those are available on our website as of today. So that's everything. Catherine, did we have any questions?
Yeah, we have a few in the queue here. So the first one is, how do you access the counts?
So let me show you. Can we see that tab, Catherine?
Yep, yeah, that's showing.
Okay, awesome. So if we're in traffic link and we go into, click on an intersection and we can go into our insights tab here. And then at the top we have continuous multimodal counts. And then like I said here, when you click on this, it's going to take you to an external link. So that's to data link. As you can see, the web address changed, and that is where we will find our counts. And this should load. There we go.
Perfect. All right, the next question I have here is, if you have an intersection with more than 4 approaches, can you count or differentiate each leg?
A good question. I think we only do 4 as of right now. I know with our Scout product, it's more customizable. I'm not too sure of that answer, but I can hopefully get back to you about that.
Perfect. So yeah, we'll send you a follow-up on that. All right, next one is, do you have instructions or recommendations for conducting manual verification counts of bicyclists or pedestrians?
It's a good question. So we don't necessarily have a methodology that we recommend for that. What we do is that we do have people on our team at Miovision that review video and review kind of bits and pieces of video from various locations for various different types of vehicles, so vehicles, pedestrians, cyclists. They manually review that data to check for accuracy, and where they see that the algorithm has kind of misassigned, so maybe they said it was a cyclist but it was a pedestrian, something like that, then they can kind of correct that, and then that learning gets applied to the next update to our algorithm that gets pushed out to all of the cameras out in the field. So we are constantly learning. We do have people specifically at Miovision that do check the video periodically. But as for specific locations to do kind of an internal audit, we don't necessarily have that. I would recommend maybe just looking at a couple 15-minute periods in different lighting, different times of day. That's generally how we go about it, just to see what is affecting accuracy, if anything. Maybe we're great across the board, maybe there's some some lighting issues that could be improved, or maybe we just need to move the camera. That's sometimes something that we see.
Perfect. All right, next one we have, our experience is that the Miovision devices are still missing or undercounting people walking and cycling if they are crossing at an unexpected place or an unexpected direction. How have things improved with detection, and also how are other micro-mobility devices such as e-scooters being counted?
Sure. So great question. So obviously pedestrians and cyclists are unpredictable in some aspects. So how we count them is just through the intersection, as I showed you with our configuration, and we count pedestrians in the area where we put our pedestrian crosswalk. Obviously, if they stray out of that, we're not able to count them. If you can consistently see that they're moving in a specific location, you could move your crosswalk to that location perhaps, and you can play with configuration a little bit that way. But unfortunately, if they're not in the kind of location where the majority of vehicles and pedestrians are crossing, then they won't get picked up. In terms of like e-scooters, for example, that's something that we currently can count on the Scout side of the business, so the temporary counts. That is a specific class that we can add, a customizable class that we can add. So we have been building our library of instances of that, so we're improving there. We don't have it currently as a vehicle type for the 360-degree cameras. I'm not sure of the plan for that, but I do know that we're building that library. So it would make sense that in the near future, obviously more and more scooters are coming into our cities. So it would make sense, and we are able to do it in some respects. So I assume that'll get pushed out eventually.
Perfect, and I'll group this one together because it's related, but do you know the estimates at the moment for accuracy of bicycles and pedestrians?
So I believe that our accuracy is 95%, 90% of the time, which is a mouthful. But we are still actively working with a few customers to continuously improve that. And we're coming up with ways of making sure that before we even install something, that we know if it's a priority for pedestrian and bicycle count, so that we're really aware of where we're placing the camera to optimally count bicycles and pedestrians, especially where at certain angles, cyclists and pedestrians can look the same because we can't necessarily see the bicycle depending on the angle. So we are really working on improving that accuracy from a computer vision point of view, but also knowing exactly how to best set up our cameras to collect that data.
Great. All right, now a couple of questions on the red light runner. So does red light runner capture people turning right on red?
No, it does not. So it's just the through movement for now. If that's something that is very interesting to people, then, I mean, just based off of this comment alone, I've heard it from a few other people, then we're absolutely interested in providing that. Obviously, we have all the pieces of that data. We know what's happening at the controller. We know when people are turning right. So we have all those pieces of data, but we haven't yet put them together.
Great. And can you filter vehicle type in the red light runner analysis?
We actually just got this question a couple of days ago too, and I thought it was brilliant. Right now, no, but that's a really exciting one in my books, because again, you could kind of filter out cyclists maybe, or especially filter out emergency vehicles. So that's also a really, really good idea. For now, no, but I think that's the great idea. And again, we have all those pieces of information, so I don't see why not.
All right, next is it possible to count vehicles that stop at the red light in the pedestrian crossing zone?
So like merge over the zone. Not to count them necessarily, but you could set up kind of a detection zone, and you could get occupancy information about when vehicles are occupying a zone that is basically the crosswalk. So you would know kind of what percentage of the time vehicles are in the crosswalk. So it wouldn't be a count, but you could do it another way with detection.
Great, and I've got one more here. Can speed of vehicle be measured and displayed on screen?
No.
Oh, and just a qualify, they said estimated speed, but
We have like estimated speed in some of our corridor metrics, but just on like a vehicle by vehicle basis, we don't have speed right now.
all right, perfect. So I don't see any more questions in the queue. So again, if you have questions down the road, feel free to reach out to us, to your partners, to your CSMs. We're always happy to answer any questions you may have. And otherwise, thank you, Olivia, for your presentation today, and keep an eye on your inboxes as we'll be doing another one of these next month.
Thanks, everyone.
Thanks, everybody. Bye.